Hello and welcome back to the channel. In today's video, I'll be showing you how to blur faces in images, as many faces as possible in images. The first steps that we're going to be taking is we are going to be acquiring the image from any URL that you put into it, and we're going to be detecting the faces from this particular image. We extract the face location, we blur the faces, and then we do the replacement of these blurred faces in the actual image. Afterwards, we just display it, but you can choose to do whatever it is you like with it, like saving it or doing any other manipulations with it. So let's get into it and get started. I will be using Colab for this tutorial. You can use any IDE you like. So far it has GPU support, or you can use this same code on the CPU. The only downside is just that you will not have a faster processing as compared to the GPU side. We'll just change our runtime from CPU to T4 GPU on the Colab so we can run on GPU, and I'll do the connection. So by clicking connect, Colab is going to reserve a temporary GPU for me that I can use for the processing. Okay, so the first thing I need to do is bring in the libraries that we'll be using. We'll be using the MTCNN and OpenCV Python. If you come to pypy.org and you search for MTCNN, you should see the documentation in here on how to detect faces. MTCN is a face detector for Keras. However, we are not going to be using only this one. We are going to be using the OpenCV package too. I'm going to duplicate this where we can have OpenCV Python. And you can see we have this latest package, and you can see some of the installation and usage instructions for OpenCV as well as MTCN. Those are the primary two packages we are going to be using. However, under the hood, we are going to be also using another package, and the package is Pillow. This is the Pillow, PIL. Pillow. Yeah, we're going to be using Pillow 2 under the hood. So for getting some of this data and visualizing some of this information we have in our code base. But anyways, that's just the brief overview. If you need to go into more deeper into the documentation, you can click on the documentation for each of them, and you can see for the home page in here, you can go to the home page, and I think they have some pretty nice documentation in here too. Then for the open MTCNN, you can go to the home page also, and you can see the code and the sample code you can use. Anyways, going into this, we are going to go back to our Colab so we can start diving into the code properly. So I'm going to be installing the MTCNN. So I'm going to have pip install MTCNN and OpenCV Python. So by default, Google Colab supports Pillow under the hood, so we don't necessarily have to specify the installation. If you want, you can add Pillow to it, but it's fine. Under the hood, it's already installed. So the first thing we need to do, we're going to be going through 3 different steps. The first one is going to be the acquire the image that we want to use. All right. The second thing is going to be, we are going to be detecting the faces from this image, detecting the faces from the image, as many faces as possible. Then we extract these faces, extract face locations, and then the last thing we are going to be doing is we blur the faces, and then we replace the faces, okay, the faces in the image. Okay, all right, so technically these are 5 steps, so we're going to be going through them one after the other. So because we are going to be going through multiple algorithms, I think we are going to have some reusable functions to make things way easier, so we don't repeat so much code in our code. All right, so I'm going to add 2 functions. So I'm going to bring in the packages that we're going to be using, import CV2. Then from Pillow, I'm going to be importing image. This is going to be useful for reading the image URL for us. I'm going to be using NumPy as NP, and then we're going to be using IPython for display. So IPython, python.display, I'm going to be importing display. So these are the basic packages that we're going to be using for in our code. All right. Though we have some more codes, but for now we're going to be limiting this for now. By the time we start writing our functions, we'll be importing the packages as expected. But they are not going to be more than these general functions. Anyways, so the first thing we need to do is to acquire the image. So how do we do that? We have a function called def image. No, not def image, it's get image, and this is going to be coming from a URL. So we're going to pass a URL to this get image, and we're going to be needing a request package for that. And then from IO, the input and output, we're going to be importing bytes IO because we want to read the URL from the image, from the image from the URL rather. We're going to be importing the bytes IO, and you see how that works. If you've been following the tutorial, we've been using this kind of function for some time. But anyways, if this is your first time in the channel, this is how to use the bytes IO to read the image from the URL. So we're going to have a try function where we are going to be fetching the image from the web, okay? From the web. And how do we do that? We have a result variable where we're going to be storing the request that we get. So we are going to be getting this data from the URL, all right? And if there's an error, we're going to raise an error, raise for status. Okay, so this is going to allow us to raise HTTP error for bad responses or bad requests. It doesn't really matter which one, request or response. So the next thing we do once we have that, we're going to be storing that into a pillow image. So we are going to be convert to pillow image, which is going to be, we are going to have our image as a image.open from pillow. We're going to be using the bytes IO to read the content of the results because it's going to be image. All right. So once we do this, the only thing we need to do is return this particular image. So this reads the image from the URL, and we can have an exception because we're doing a try except. So we have request.request exception as E, and then we can just print. Okay, just say an error occurred. I'll just call the error E. Okay, now this function, each time we want to get the image from a URL, we use this function get image to get the particular image from any URL that has an image endpoint. Okay, so the next thing we want to do, I'm going to run this. So the next thing we want to do is we want to have another function where we can display the image. So this is going to be display image. All right, I'm going to have img as the input, and I'm going to have image numpy. So the first thing we want to do is convert from BGR to RGB, because for processing, OpenCV uses BGR. So for us to see the real color, we change that to RGB, which is how we're going to be doing that right away. So we have the CVT color. I'm going to have the image, which is going to be converted from CV to color BGR to RGB. All right. Okay. And in fact, let me just comment this out. I'm going to have convert BGR to RGB. So in a case where we are going to, once we are done converting that, we can now display using our display from IPython. So we say we convert back to pil image, and then we display. And how do we do that? We just say display image from array, and that's going to give us our image numpy. Okay, so this is going to, anytime we pass an image numpy, the first thing it's going to do is going to convert that to pillow and then display with IPython. So those are the two functions that's going to be recurrent to be used. All right, so once this is done, the next thing we want to do is we want to go for the OpenCV implementation of this package. Okay, so I'm going to start with the just direct blurring of how to blur the image using OpenCV. without MTCNN, for instance, so we can compare the output and the result. Okay, I'm going to have a function. I call the function called blur faces. Okay, and I'm going to put the image in there. So I'm going to for this particular blur faces, I'm going to load the R cascade for face detection using OpenCV. Right? I'm going to load the R cascade for face detection. And this is going to be face cascade. It's going to be cv2.cascade. That will be cascade classifier, if I'm correct. Classifier, right? So this is going to take a single argument where we're going to have the data that we want to use, the XML, which is the R cascade. All right. Then we're going to pass in the XML that we want to use, all right, which is the R cascade frontal face default.xml. So that's the XML that we're going to be using. And then once we have the face cascade, we can now convert our image to NumPy, which is going to be to load the image. We're going to have our np.array to convert that to NumPy. Once that is converted, we just need to, it's loaded, not really converted. So we now convert from RGB, which is the normal red, green, and blue, to the blue, green, and red, which OpenCV uses. So we're going to do convert to RGB to BGR. This is what OpenCV uses. OpenCV uses BGR. All right. So the next thing we need to do is just cv2.cvt color, and we have the image that we want to convert. We have the cv2 dot that will be color RGB to BGR. Okay. And once this is done, I think we can now do the detection on that particular image. I'm just going to shift this up a little bit, and I'm going to have, this is where we're doing the detection of faces. So we have our faces. It's going to be face cascade dot detect multiple faces, multi-scale, which is the multiple faces. All right, from the image, we are going to have a scale factor 1.1. Then the minimum neighbors, you can look at the specific meaning of each of these parameters in the documentation, and we have the minimum size. Mean size is going to be 30 by 30, 30, 30. All right. Now, once that is done, this will generate the faces that has been detected. Okay. If you want to know the number of faces, you can do something like print the length of faces that are detected are going to be here. Detected. Okay. I don't need that. Yeah. Now, for each of the faces that has been detected, it could be one, it could be as many as possible. So for each of them, we're going to have a tuple, the x, y, the width and height of each of the faces that has been detected. And then we are going to be selecting our region of interest. Select region of interest, which is going to be the image that we have. We are going to get the y-axis, and then we're going to go from the base y to the highest height. Then we do the same for the x. We go from x to x width. So it's going to go from, if it is x, it's going to go horizontally. If it is y, it goes up to get the regions that we want to blow out. So once we have our ROI, the next thing is to blur that particular ROI. So we blur the ROI, which is our region of interest. I'm going to say ROI, okay, just in case. So we just have a blurred ROI, is going to be cv2.gaussian blur. We're going to have ROI, and then the Gaussian blur we want to do is 99.99, and then we put a 30 there. So you can look at the specific parameters in the documentation. Anyways, so the next thing we do is we replace that particular region from the original image array. Okay, so we have to replace the original region in the image with the blurred region. All right, so now do we do that? We're going to have our image, which is going to be starting from the y plus h going up, and then the x going from x to the last end of the width. So we're going to replace that with the blurred ROI. All right, and that's it. This technically has replaced the image in the background. The next thing we just need to do is display the image. Okay, and yeah, that's it. We just go out of the function. Now we can use our function to get to test. So we have our image. We just do get image. We're going to go to Pexels. I'm just going to go into pexels.com, and I'm going to search for faces. I have this really nice face in here. I'll just copy this. I'll just open this. I'll copy the image address, and I'll paste this here. Once that is done, I just need to continue and blur the faces because I just read the image. The next thing is the blur faces, okay, with the image. If I run this, hopefully we don't have any error. So we have the RBG to BGR. It's not RBG, it's RGB. It's RGB. I know some of you catch that, and just rerun that. Is everything okay? Okay, so we have the blurred Gaussian blur, cv2.gaussian blur. I think there is a spelling error in there. Let's see, cv2 Gaussian blur is Gaussian, not Gaussian, and we should be good afterwards. Yeah, one face is detected. Can you see? And let's see if we are able to blur the face that is detected. Okay, so I think it's currently here detecting the face, and it's not replaced. So let's see why it's not replaced. We're using the image, the original image that we read from here, which is not what we want to display. We want to display the replaced image, this IMG. I think we just need to rerun that, and we should be good. Okay, and you can see these are the faces that are detected, and yeah, so instead of display, it should be display image. If you remember, the function we had here is display image. All right, so that should we don't need this anymore. We'll just comment that, and we just rerun. Right, so I think it's displaying the image now. If you look at the RAM, the GPU RAM is not being used at the moment, but we are going to get the part where it's a little bit more interesting, where we can leverage the power of the GPU to do the blurring. And this is beautiful. We can see that we have the face. You can see the face before, and you can see that there is an overlay on this particular image, which is blurring the image in particular. Okay, so since that is done, the next thing we want to do is explore another algorithm where we can use a different method to blur this the same image, but in a different way. So instead of this transparent or translucent overlay, we can use something more like a pixels on the image, and I'll show you how to do that in a second. So I'll just come back in here, and I'm going to have another function. In this function is going to be a pixelate function where I'm going to change the overlay into pixels, and this pixels is going to enable us to overlay the image, but instead of the translucent overlay, we're going to have more of boxes, like pixels on this image. So I'm going to just write a simple function to do that. I'm going to have, so let's say pixelate faces, all right, the image. And don't worry, we're going to be testing this as much as possible with different images so we can compare and contrast which of these functions are more efficient. So I'm going to be copying this same code. I'll just leave that here, and I'll just put that in here. Okay, so to save some time. So once that is done, then for each of the images that I have, in fact, I'll just let's see, I'll just copy this part. Yeah, I'll just copy this part. So we can just do a copy paste in there. Now for this ROI that we have, we are going to get a small pixel, a tiny pixel of this image. We're going to do CV2.resize. Okay, I'm going to resize the ROI to 10 by 10. And the reason why I'm doing this resize is because I want the pixels to be very small, not too small, but small enough so I can overlay them on the ROI. So I'm going to have a pixelated ROI, which is going to be my CV2.resize. I'm going to have the boxes, and I'm going to have the width and height for replication, and I'm going to have my interpolation as a CV2.internearest. Okay, now I replace so this is where I'm doing the replacement. I replace the regions, which is the y plus height, then the x plus width, okay, to go horizontally or vertically. I'm going to have my pixelated ROI. Okay, and technically, if I just do display image, which is img, I should be good. Now this time around, I'm going to use the same URL that I have in here, so we can so instead of the blur faces, I'm going to change that to pixelate faces. All right, I'm going to run this again. Hopefully there are no errors. Okay, there is. Let's see, there's an error in here. So it says not image, is img. Why do I keep typing image? Let's see, what else do we have? Okay, it's trying to display the image now. All right, let's look at it. Nice and beautiful. So this is not so much distinguishable. You can't really see or know who this person is. However, this you can still do some, some deduction as to who this person is, if this person is who this person is really. So, but technically with this, it looks like this is messed up a little bit, so you can't really say for certain who this person is, or you can't even deduce who this person is. So this is another way to do the blurring. So the next part that I want to show you is how to use if you look at our GPU, we are not really using the GPU right now. However, if you want to use the GPU, that's where the MTCNN comes in. It's going to be using the convolutional neural network to do the pixelation. So I think I'm going to be using the second method and combining that with the CNN, so we can use the machine learning model to detect the faces and blur them using the pixels. All right, so the first thing we want to do is bring in our MTCNN package. So this MTCNN package is going to be the one to help us do the blurring and all. So not to talk much, let's just get into it. Okay, I'm going to have the pixelate okay, pixelate faces, but this time around with MTCNN. All right, so I'm going to put in the image in there. Now I'm going to be importing the package MTCNN. I'm going to be importing MTCNN. All right, so I'm going to have an image converted to NumPy array image. I suppose you can use Pillow, but you still need to have another additional step to do that. I'm going to have cv2.cvt color. I'm going to have an image which is going to be cv2.color to do the conversion RGB to BGR because we want to do the manipulation so it's OpenCV. All right, so our detector is going to be the MTCNN. So if you look at the faces that have been detected, detector.detect faces, I'm going to put the image in there. Then this gives me not faces because we're going to have multiple faces anyways. So we have for face in faces, I'm going to be extracting the XY axis just like I did in here, but I'm destructuring everything at the same time. So to save some lines, I think I can do the same. I'll have the XY width and height in faces. Then I'm going to, in fact, don't let me do that because it could get a little bit messy. I'm going to have XY width and height in my face. I'm going to get that from a box. This is the reason why I don't want to get it directly from the loop in here, because this is going to be coming from a particular box when the detector finishes. Then we get our region of interest, which is going to be the image. We get the Y to the Y height. When we get to X, we get the X to the X width. Okay. Then the same thing we did just outside this function where we are doing the pixelation. I'm going to just copy that and do the replacement. And that's it. I'll just, yeah, I'll do the replacement and I'll just do display image with the image. This time around, I'm going to copy the same in here and I'm going to paste it here. If I, this is pixelate faces MTCNN. Now, this time around, this is going to be using the GPU to do the detection. Is there any, color RGB again, color underscore RGB to BGR. I can never type that. Anyways, once that is done, we can look at our GPU this time around. You can see there's a gear up in the GPU usage, and if you look at this, GPU is getting used. We have a 1.8 GPU now. This is because the image is not the matrix in the image is not as big as you might think. So it's not using so much GPU, but by the time we have higher resolution image, we're going to be using more GPU. Let me give you an instance. So if this is being done with the GPU, and if I go back in here and I go to pixels, and I just let's say I can find an image with multiple faces. I click on this and I copy this image address. All right. I'm going to show you something, just a simple trick around that. If I paste this in here, okay, and I will run this part, this is going to give me the image. However, because of the additional compression that is being done, if I open this image in a new tab, you can see there's an additional compression which is coming from the auto compress tiny RGB 1260750. By default, Pexels is doing some amazing job to do a compression of this image from the actual size to a particular size. So because of that compression, it's going to affect a little bit if the image compression size is too small. You may not have an accurate detection. However, if you have the actual size, you could have better detection, so to say. So if you are not getting the right result or your result is not so great, you can remove these particular parameters in here, this ones. You can remove them, and then you can do the detection on actual image. And if you look at the GPU that is being used from 1.8, because I removed the auto compression, this is going to increase the GPU usage. You can see that it changes to 2.8, and you can see the output. It's going to take a little bit more time to display because of the AVR matrix in the image. However, you get the point. That's how to to play around that, just in case you have an image that is not, the output is not as expected. Now, if you want to play around this particular URL, this same one, I think I'm going to just return that. I'll just copy this, and we can do a comparison between OpenCV, the compression, the detection, the face detection from OpenCV and the MTCNN. So if I come back into Pixelate Faces and I put this URL, I'll just duplicate this, comment that, and I'll replace that with this. So I want to check, okay, I think that should be done now. Yeah, you can see the faces are pretty laid out there, and they are you can see the masking on each of the image. Really nice. Yeah, going back to this guy, I just commented out this. This is using pure OpenCV to do the detection and the masking of the faces. However, if I run this, you'll see the difference between the masking of the faces from using OpenCV and using MTCNN, and you can decide which one you want to use. All right, this is OpenCNN result. OpenCV. Nope, not OpenCNN, it's OpenCV. This is the result from OpenCV, and you can see that it's only able to mask just one of the images. This man is not being masked, and this man also is not being masked. However, if I change this and I remove this, probably we could have, let's see if we have any changes or any difference in the output. So with the auto compression from Pexels, we are able to do the compression directly, the face detection on just a single face. However, there are other faces that are not being maxed out. So with the removal of the auto compression and we have the actual image, let's see if there is a difference between the output from OpenCV. This is still running simply because it's not using the GPU, and you can see the difference in the speed when using the CPU and the GPU. Of course, is really incomparable. It's more like maybe times 10 or even more, Yeah, so this is done, and let's see if there is any difference. You can see there is a masking of two faces now because we increased the size or the dimensions of the input image. But this is not 100% feasible because you can't really say that using the CPU side, you want to be using the actual image on the CPU using OpenCV. Well, I would really advise, if you can, use the GPU side and try as much as possible to have this. Will give you more accurate detection. And that's it, folks. Thanks for tuning in. Stay tuned for the next video. You don't want to miss it. If you have not subscribed to the channel, please click the like and subscribe button. If you have any issues or any comments, please drop them in the comment section and I will be more than happy to assist you. Thank you for watching and see you in the next one.